Hey there, AP Stats students. Welcome back. For this video, we are going to discuss this last section of Chapter 10, which is 10.3, and we are going to be discussing how to find confidence intervals for estimating population proportions, okay? So 10.1 and 10.2 focused on population means. So we're going to switch gears here a little bit and look at some slightly different formulas for estimating a population mean. So before we get started here, let's kind of look at these formulas for a second. So uh, we we learned that the distribution, the sampling distribution for our p-hats is going to equal our population proportion, which is p. And then we also learned that our standard deviation of our sampling distribution of p-hats is equal to the square root of p times 1 minus p divided by n if the 10% rule checks out, okay? So if we are going to be estimating this population proportion p, our formulas are going to look slightly different, okay? So notice here how we are using p hats instead of p, okay? And that's because we don't know p yet, and we're going to be estimating p, okay? So we're going to use p hat instead of p in order to estimate our population proportion. Now also, remember, just a refresher, that this whole thing right here is what we call our margin of error, or ME. That's our margin of error. And then our standard error is just the standard deviation. Okay, so that's the standard error. All right. And also remember that all critical values, whether it's a critical Z or a critical T, all of those are always positive. Okay? And another thing to note that's important that is going to come up later on is that when we are looking at problems involving a population proportion, we always use what's called a Z procedure. Okay? So for population proportions, we always use a Z procedure. And I say Z procedure because we are going to, in future chapters, we're going to be looking at some different tests. Okay, so it could be a Z interval, it could also be a Z test. So we refer to all of those as Z procedures. Okay, all right, before we dive in, let's look at just a refresher on our conditions here. So we learned that we have to have a random sample in order to estimate our population proportion, or our center. And we want to make sure that we have a well-designed experiment or a simple random sample is stated in the problem, okay? Also, we need to make sure that our 10% rule checks out for spread. So that's to accurately estimate the standard deviation of our sampling distribution. And then also, for our normal conditions, sometimes we call it large counts, notice how we are using, again, p hat instead of p, okay? So in the past, we have checked this condition n times p is greater than or equal to 10. Well, we don't know p yet, and we're estimating p, and so therefore we only will have information about our sample, okay? So you're using your sample proportion, p hat, to check this normal condition. Okay, so there should be enough successes and failures defined as 10 or larger in order to assume that normality condition. So let's go ahead and look at applying this one proportion Z interval. So we're going to look at example number 9 here, and what it says is alcohol abuse has been described by college presidents as the #1 problem on campus, and it is an important cause of death in young college adults. How common is it? Well, a survey of 10,904 randomly selected U.S. college students collected information on drinking behavior and alcohol-related problems. The researchers defined frequent binge drinking as having 5 or more drinks in a row, 3 or more times in the past 2 weeks. According to this definition, 2,486 students were classified as frequent binge drinkers. Construct and interpret a 95% confidence interval for the proportion P of all college students who admit to frequent binge drinking. Okay, so we're going to follow our 4-step process to construct a 95% confidence interval. So our first step, number 1, is to define our parameter, okay? So what does P here represent, okay? So we're going to say let P equal the true proportion of college students who are classified as frequent binge drinkers. Okay, so always define your parameter. P, what are we talking about? What does it represent? Okay, now we're going to check our conditions. Okay, so that's step number 2 is our conditions. Okay, so condition 1, do we have an SRS? Okay, well, it stated that it was a randomly selected sample. Okay, so we will say stated in problem. Okay, condition number 2 is the 10% rule. So our population has to be at least 10 times our sample size. And our sample size is quite large, but if we add a 0 to that, that means that our population needs to be at least 109,040. Okay, and I think that if we're talking about all U.S. college students, I think it's safe to assume that there are at least 109,040 college students. Okay, and then condition number 3 for normality here. What we need to check is that n times p hat is greater than or equal to 10, and n times 1 minus p hat is greater than or equal to 10. Okay, so just as a little side note here, we took a random sample of 10,904 students, and of those, 2,486 admitted to following this definition of frequent binge drinking. Okay, so we're defining our success as a frequent binge drinking. So the number of successes that we have is going to be 2,486, which is definitely greater than or equal to 10. And then that means that the number of failures would be 10,904 minus the amount of successes. So that gives us 8,418 failures. Okay? So both are definitely large enough. So we're going to say there are enough successes and failures to assume normality. Okay, so all of our conditions are met, and now we are going to go on to the calculation portion. Okay, so we need to either A, give the name of the procedure, or B, we need to write the formula of the procedure. And I like to do both. Okay, so what we're going to be doing is a 1 proportion Z interval. So 1 proportion Z interval. And that is going to be at 95%. Okay, so the formula is going to be p hat, okay, that's our point estimate, plus or minus critical Z times the standard deviation, or we call standard error sometimes, p hat times 1 minus p hat divided by n. Okay, so it's our point estimate plus or minus our margin of error. And p hat is, we have 2,486 successes out of 10,904 failures, or total, that's our sample size, not failures. Okay, so our p hat is 2,486 divided by 10,904, our sample size. Okay, now n is equal to 10,904, right? That's the sample size. And then critical Z is going to be, for 95%, it's going to be 1.96. Okay? All right, and you might have that memorized. You know, it's nice to get the really common intervals, the 90%, the 95%, and the 99% confidence intervals. It's nice to get those values memorized because we use them so frequently. However, if you do not have that memorized, remember what you can do is you can do an inverse norm, and we would set our tails to be, the area of the tail would be, well, 100 minus 95 would be 5% on each side, so cut that in half, it'd be 0.025 on each side. Okay, so then you can either you can plug all of these variables right into your formula, or what you can do is you can press the stat button on your calculator and you can find that test menu and you can select a 1 prop Z test. Okay, so not a 1 prop Z test, a 1 prop Z interval. Okay, we're doing an interval. Okay, so a 1 prop Z interval on your calculator. It doesn't matter whether you plug it in to the formula on your paper and crunch the numbers, or if you use your test or your calculator test. Okay, so what we should get, I'm going to just kind of speed us up here. What we should get as our final answer is the interval going from 0.22 to 0.24 approximately. Okay, so do take some time to look at that interval on your calculator. Again, it's under the test menu when you press the stat button. So our fourth step here is to make our conclusion about our interval. So that means we need to interpret the interval in context. So we're going to say something like, we can estimate with 95% confidence that the true proportion of college students who partake in frequent binge drinking is between 0.22 and 0.24. Okay, so let's write that up. Okay. All right, so the 4 steps are the same, whether you're using a one sample Z interval or a one sample T interval or a one proportion Z interval. However, if we are constructing an interval for proportions versus population means, our conditions change slightly. Specifically, the third condition, this normal condition, changes slightly. And then obviously we are going to have a different formula, a different test and a different formula. But, step number 1 and conditions 1 and 2 and step number 4 all follow the same process. Okay? So go ahead and flip to the next page, and what we're going to discuss is finding sample size to achieve a certain desired margin of error. Okay, so we know that this specific formula right here represents the margin of error for a one proportion Z interval, and what we're going to do here is we're going to set it equal or less than this desired margin of error. Okay? So again, make sure that when you are solving for this sample size, that you always round up. Okay? So let's look at this last example, number 10. It says, suppose that you wanted to estimate P, which is the true proportion of students at your school that have a tattoo, with 95% confidence and a margin of error no more than 0.1. We want to determine how many students should be surveyed to estimate P within 0.1 with 95% confidence. Okay? So we want our margin of error to be no more than 0.1 with 95% confidence. Okay? So our formula then would be critical Z times the square root of P hat times 1 minus P hat divided by N. Okay? And that's going to be less than or equal to 0.1. Now, critical Z, okay, for 95%, we did one just a second ago, and like I said, you might have this memorized by now. When you do enough of these, you know that, 90% is 1.64 and 95% is 1.96. You just, sort of get them memorized. Otherwise, you can do an inverse norm, remember, and set your tail equal to 0.025, which is half of 5%, to find that critical value, and it's always positive. Now, we run into a slight problem here because we do not have any information about P hat, okay? We're looking for sample size, and in order to find P hat, we actually have to know sample size, right? So, P hat is equal to the number of successes divided by n, our sample size, right? And we're actually looking for this number n that ensures that we have this margin of error that's no more than 0.1. So we kind of come across this interesting dilemma. So since we do not have a sample proportion, what we're going to assume is that there's no difference between the number of successes and failures, okay? So let me write that up. So we're going to assume no difference between the number of successes and failures. So what that means basically is assume that there's no difference between p hat and 1 minus p hat. There's no difference between those two, okay? So what that means is that these two are equal to each other, okay? And the only physical proportion that can be equal is if both of them were 50%, okay? So we're basically going to assume that p hat is 50% when we do not know it, okay? And you might come across a couple of these problems that ask you to find a sample size for a proportion, and that's when we need to assume that p hat is 50%. So we're going to go ahead and plug this in and then just solve, okay? So what we have is 1.96 times the square root of 0.5 times 0.5 divided by n, and that is less than or equal to 0.1, okay? So the first thing that you want to do is you want to divide both sides by 1.96. So go ahead and do that. And what you should get here is the square root of you know what, I'm going to go ahead and multiply 0.5 by 0.5, and that gives us 0.25. So 0.25 over n, then take the square root, is less than or equal to 0.051. Okay? So now we are going to square both sides of our inequality here. Okay? So that means that that's going to cancel out our square root, and we are going to get 0.25 over n is less than or equal to 0.0026. Okay? So now what we're going to do is you can do this a couple ways, but technically you would multiply both sides by n and then divide by 0.0026. So I'm going to just rewrite it, 0.25 divided by 0.0026 is less than or equal to n, okay? So that means that n needs to be greater than or equal to about 96.15. And remember that we always round up, okay? So larger sample sizes give us smaller standard deviation or smaller variability, which affects the margin of error, okay? So if we want that sample, or if we want our margin of error to be within 0.1, we need to make sure to round that number up instead of rounding it down. So n has to be greater than or equal to 96.15. So that means n has to be 97. Okay? So let's just make a quick conclusion here. It means that we must sample at least 97 students to ensure that our margin of error is going to be within 0.1. Okay, so now that you know or you've learned quite a bit about confidence intervals, you might enjoy this nice little joke at the bottom here. I want you to stay tuned for the next video, which I'm going to briefly kind of review some of the concepts from Chapter 10 and then kind of give you a heads up about what you should know for the Chapter 10 tests, okay? And remember that practice tests are going to be due the day that you take the Chapter 10 exam, and those need to be completed with all the steps, and then you need to make sure that you grade it with your pen. And after you take your exam, we are going to start on Chapter 11, okay? So thanks for watching the video. I hope you guys have a lovely day and stay tuned for the next video. We'll see you soon.